Hello everyone. So continuing from our last video, so where I showed you guys like how to set up OpenSSL. So if I open up my server, yeah, Wails is running, and if I can increase this thing, so, and let me connect to my hub. Okay, and if I go start streaming, yeah, so I was able to showcase this. Okay, so my camera is reading the web page which is served by my hub. Okay, and I'm able to stream out videos. Cool. Now in this video I'm planning to implement how to develop our HandleIngest endpoint. Let's make it a bit here. Yeah, cool. Yeah, now let's discuss like what will happen in HandleIngest. Let's go with this. Okay, so in our previous design, so what was happening? So our Wails desktop app, okay, this guy, so this will be uh, watched by many viewers. Okay, so let's say v1, v2, v3. Okay, these all people will be like connected via our Wails desktop app. Okay, and they will be communicating with our hub. Okay, now to this hub, all the devices that I have, okay, they will be actively sending their camera feed. Okay, basically the frames. Okay, so in our last video we have implemented this part, like my phone was able to get connected to my hub and it was able to stream the videos. Now we have to implement our HandleIngest endpoint. Okay, now this HandleIngest endpoint will be kind of the core of our project. So in this endpoint we will be accepting frames from our devices and then channelizing it to our viewers. Okay, now yeah, this will not be a pretty simple task. So here, so it not just about channelizing. Okay, it's all about like maintaining the connection between hub to device as well as hub to our viewers. Okay, which is like our desktop app. Okay, so when we are like maintaining this WebSocket connection or the underlying TCP connection, so a couple of things we need to take care of it. Okay, first thing is like we have to check if both the parties are connected. Okay, so right now in my hub, which is my relay, okay, that needs to check whether viewers are there. Also it needs to check whether devices are still connected. Okay, so for that we will be implementing a ping pong setup. Okay, so this thing will be for my viewers. Okay, so if any viewer, let's say, disconnected, okay, so the hub should have a mechanism to know whether someone has disconnected. Okay, then there is let's say there are some disconnects happening from my device end. Okay, let's say my Wi-Fi switches, or if I have a very bad network, okay, something like that, then I should be able to so not wait, but let's say after some time the connection uh, like stabilizes. Okay, and this device retries to send the frames. Okay, so I'll be able to again accept its frame. Okay, so disconnection handler. Okay, now the third part will be, so this guy will be sending me some binary data, right? So because it is directly feeding on the frames. Okay, so I need to create a byte object. Okay, that I'll be relaying to my viewers. Okay, and later on the React or Wails will take care of like transforming it into proper image so that it can display in the desktop app. Okay, so it will be like uh, data packets, I can say, data or network packets, um, you can say build. Okay, cool. And the most important thing here will be, so it's not just with one device and handling one viewer everything is good. Okay, but in that same WebSocket connection we are like implementing ping pong as well as disconnection handler. Okay, and also sending out to viewers all that frame. Okay, so multiple go routines will be involved here. Okay, mostly like here one go routine will be involved, which is for the ping pong handler. But yeah, since more than two go routines are there which will be writing to the same WebSocket connection, so there we will need to handle locks. Okay, because since I'm using Gorilla Mux package, so you can think of it's kind of a rule there. So so multiple go routines cannot write to the same WebSocket connection. Okay, even if the go routines are ready to send the data, I have to create a blockage where one go routine can write at one point of time. Okay, so yeah, these will be the implementation details. So yeah, let's start coding. So where are we? We are here. Okay, so let's first create a map to create a, so I will be creating a map. Okay, let's call it where um, writer, we'll call it mutex, and let's create a sync map. Okay, so what will be so what this guy will be carrying is, per WebSocket connection it will be carrying its own write lock. Okay, why do we need it? So as I told, like we will be doing this ping pong handler as well as we will be sending out frames. Okay, so two go routines will be writing to the same WebSocket connection. Okay, so using the lock for that WebSocket connection I can like put a blockage. Okay, so that only one go routine will be writing its stuff in that WebSocket connection. Okay, so yeah, now what all write-ups will we be having? Okay, what all writes we will be doing? Okay, so first one will be we can think of so yeah, first one will be like sending some messages you can think of. Okay, so these messages are something like okay, let's say we have the viewers. Okay, and a new device is like now sending frames. Okay, so some kind of a notification we should send to our viewers, right? So the sending messages can be our notifications. Other thing will be, let's say a device disconnects. Okay, disconnection. So any kind of notifications you can think of this. Okay, and since we will be like since this notification should be human readable and all that, so we will keep it to like, we will be writing JSONs here. Okay, then another form of write we will be doing is which is, so in that WebSocket connection we will be like sending out frames, right? So those frame will be of binary data type. Okay, so we'll be sending bytes. Okay, or binary data you can think of. Okay, and then the last write we will be doing is on the ping pong handler. Okay, so we will be setting up a WriteControl. Okay, so we could have used this kind of write for ping pong handler, but yeah, it's so web control kind of writes are those kind of writes which are like for our controlling our WebSocket connection. Okay, so they should be very fast. Okay, and so why they need to be fast? Because they need to maintain the WebSocket connection, they need to check whether the device is alive or not. Okay, so in order to do that, so all those operation needs to be like efficient or very fast. But when we are sending bytes, those are like expensive and slow operations. Okay, so yeah, that's why we'll be using WriteControl. So you can search for like WriteControl in WebSocket. Yeah, think you can find some details here. Control messages, yeah. So yeah, three type of writes we will be doing. So first, let's create a helper functions to get the corresponding mutex for or the lock for our WebSocket connection. Let's call it con mu, and we will be getting the WebSocket connection, and this will be like key for our map. Okay, and we will be returning a sync mutex. Okay, then I will get the mutex, then write mu, then it has a load or store method, which basically like if the key is not there, okay, then we can directly put some default value there. So I'll be creating a sync mutex, and I will be placing there. Okay. So it's like something if the connection was not there in our map, okay, then I will be by default creating this mutex, okay, and I will be storing that for this WebSocket connection. Okay, so it's, you can think of like it's like a default dict in Python. Okay, then I'll be returning this mutex. So yeah, I'll be type converting into sync mutex. Cool. Oh yeah, oh, it has a hot reloading. Cool. Let's stop it. Let's close this. Then let's implement our first write, which is let's call it safe write JSON. Okay, so we'll be taking this WebSocket connection. Okay, and it will not return anything, or it can return, oh yeah, also the data I need to send. So let's call it the value, and at max it can return an error. Then I'll be first collecting the mutex for the WebSocket connection. So I'll be calling this function and sending my mutex. Then I'll be putting a lock here. Then let's defer with the unlock. Okay, cool. Then I'll be setting a write deadline. So within this deadline, we should write. So whatever time it is, I'll be adding a, let's say, a 5-second timer. So within 5 seconds I should write whatever things I need to write. Okay, then I will return c dot write JSON. Okay, and I will be putting the value v. Cool. Then so this is for our notification. Then for sending out the frames, so I'll be writing like creating this safe write binary maybe, or let's call it message, because yeah, the frames are the messages for my views only, so there is no interaction between device and the viewers. So let's call it WebSocket connection, and it takes it should take the frame object itself, as well as when I'm writing messages in WebSocket, so it takes a let's call it I think it takes the message type also. Let's call it WriteMessage, gorilla. Byte object, WriteMessage. Oh yeah, text message. Yeah, it takes the type. So okay, cool. So I'll be taking the type also. What kind of message I'm typing? Message type. It will be an integer type. Then whatever data I'm sending, so that will be in byte format. And yeah, same as WriteJSON, it will be returning an error if something goes wrong. Okay, now again let's collect the mutex for my WebSocket connection, and okay, then I will be again performing a lock. Okay, I will be deferring unlock. Okay, then I'll be again setting a deadline. Let's copy this. So again we can use the same 5-second thing. 5-second thing. This, then yeah, here I'll be needing write message. Okay, so here I will put the message type and the data, which will be framed here. Okay, then the final function, which is the WriteControl. Okay, so this I'll be needing for my ping pong setup. WriteControl, see WebSocket connection, and here again I can take the message type. Okay, and it takes the byte data. Let's open this here. Okay, and then you can put a deadline. Okay, so within this time we should be able to write. Okay, again same stuff. Okay, and here I can do a WriteControl for the message type. Okay, and I can directly use the deadline here, so I don't need this manually setting a deadline. WriteControl already has the deadline thing. Cool. And I can also put one more function. So yeah, so let's say one of the viewer disconnected. Okay, I should remove that viewer from my map, which was like viewers. Okay, so let's create this. So so basically what does that mean? So that viewer disconnected, so it will be removed from my map. But yeah, this is for my mutex, so I should remove that WebSocket connection from my map. Okay, so let's call it forget connection. See WebSocket con, and it returns error. Okay, then mutex. So just like all the map operation we have in Golang, it also has a map operation. Oh yeah, it should be capital. It takes C, and I should close the connection. C dot close, and I can return this. Close should return error or something. Okay, cool. Yeah, so these functionalities will be needed for per WebSocket writes. Cool. Now let's implement our HandleIngest. Yeah, good. So again, so initially this will be like HTTP request response writer. Okay, and request object. So we need to convert it into WebSocket. So so error not equal to nil. So our handle hub has a upgrader. Then we need to upgrade to our WebSocket. Okay, cool. Then I can say if error is not equal to nil, I can simply put a log message. So like fail to establish WebSocket WebSocket connection. And do I need to provide anything? I don't need to provide anything. I can use println then. Okay, and I need the log package. It's a tab return. Cool. Yeah, then yeah, then I can defer my forget connection also. Okay, and here I will be writing this. So if my viewer disconnects, then I'll be removing that viewer. Okay, like removing that viewer's WebSocket connection from my map. Okay, cool. This is for my defer. Okay, then what I need to do? So first what is happening here? So how my hub and client are working? Okay, so if I show you here, yeah, this part only. So whenever my pump is starting, or like the HTML page, like when I'm clicking on the start stream button, okay, then this guy first creating a metadata, right? So that metadata will be used to get the device ID, in which room I have placed the device. Okay, so and what all like resolution of frames I will be getting, in what FPS. So all that information, so the device first sends to me, right? So I need to capture that. So I'll be doing a little JSON marshalling here. Cool. So let's first get the message. So error c dot read message. Okay. Then if something goes wrong, I can log something like fail to collect message, and I can return from that. Okay, now once I have the metadata, let's put this collecting stream metadata. Okay, then I need to store it into my first convert into my proper struct format. Okay, so meta, let's call it meta, let's create this. Then I need to unmarshal it. So if error is not equal to first JSON dot unmarshal, so take the message, take the pointer to my meta, unmarshal it. Okay, now if something goes wrong, or I can put another check if device ID is not there. Okay, it's an empty string. Then I can log some useful message here. So something like bad metadata, and I can put an error here. Okay, and I can return from that. Cool. Now cool, so device ID is pretty important for me. By room, rooms are not that important. So I can remove this. Yeah, rooms are not important. So by default I can set room like room as my home. Okay, so I can create a variable maybe on the top, const let's call it default room equal to home. It should be string. Okay, cool. So I'll check if meta dot room equal to empty. Then I will set meta dot room equal to default. Why is it not taking? I said it here, right? Oh yeah, if yeah, cool. So with this I have collected the metadata which is sent by the HTML page. Okay, now I need to notify all my viewers like a new device has connected. Okay, so let's put a lock here. Okay, so this is for like so all this handler will be running as separate Go routines, right? So it's wise to put a log here and collect all the. So what is happening? So this same endpoint is being used by multiple viewers, right? So whenever we are like collecting some data from a data structure, okay, then it's always wise to first lock it, get that data from the data structure, and then unlock the lock. Okay, and do your processing. Okay, so here I'll be first checking that so here I'll be first doing the disconnection check. Okay, so let's say the device was earlier sending me frames. Okay, so I would have the old connection to that device. Okay, but if I'm again getting that device ID, okay, which means I have to remove the old connection and register this device as a new device ID with a new WebSocket connection, right? So yeah, so I'll check if in my ingest, okay, in my hub ingest, okay, this device ID was already present. Okay, so meta device ID. Okay, now if old is not equal to nil, which means the WebSocket connection was there, and the new connection that I have, okay, that is not the same as my old connection. Okay, then I will simply delete it, the old connection from my ingest device ID. Okay, then I will re-register the device. Okay, so re registering or simply registering. Okay, but if it's first time, registering, I forgot the spelling. What? Register. Yeah, register. Yeah, register. Yeah, registering. Cool. So handle.ingest. I will say metadata.device with this connection. Then what else? I can update the last scene with current timestamp. Time.now milli. Can use milliseconds. Yeah. Then I need to update the device ID metas. So meta.device ID. So in this mapper I was storing the metadata for the device, right? So yeah, so I'll say meta. Cool. So here I only need to remove the WebSocket connection. Okay, I don't need to perform the delete operation here, because this line will automatically get updated, right? If it was a kind of a disconnection kind of a scenario. Okay, cool. So then I need to notify all my viewers. Okay, like a new device has registered, or the old device has re-registered. Okay, so let's open this in the background, and this has my code. Okay, cool. So let's say collecting all viewers, okay, of the room. So let's create an array, room viewers, and it's array of my WebSocket connection. So this array will be containing the WebSocket connection to all of my viewers. Okay, this thing. So yeah, first I need to check if I have some viewers already in the room. Okay, dot viewers meta dot room. Okay, if there are some viewers who are watching in the for that room. Okay, so I'll collect all the viewers. So for viewers in range, we set then room viewers equal to append room viewers with v. Okay, cool. This yeah, not equal to nil. I have appended this. Why is it saying yellow? The result of is never used except maybe in other appends. I'll be using room viewers. So yeah, cool. So yeah, the setup is something like this. So I have my room. Okay, so what is happening here? Okay, so how it will act is, so let's say this is my blueprint of my entire place. Okay, or my flat. Okay, so I have my room. Okay, let's say this A is my room. Okay, let's say I have something like this kind of a structure. Okay, let's say my friend's room is next to me. Okay, that's a separate room. Then I have like bathrooms, let's call it bathroom 1. My friend also has a bathroom 2. Okay, then we have our kitchen. Okay, kitchen is also treated as a room. Then I have my hall room. Okay, so I have 6 rooms here. So whenever I will be placing my phones, okay, I'll be placing in different rooms. Okay, now so for that room I will have different viewers. Okay, which will be seeing what all devices are capturing frames in that room. Okay, so yeah, this is for that. So I will first check what all so how many the list of viewers that I have for that room. Okay, Then I will simply collect them. Now I will send a notification to them. First I need to unlock it. Okay, then I can say I didn't close the connection. Okay, I need to close the connection here. This and I can forget the connection here. Cool, and this is set. Then I can have a check if len of room viewers is more than 0, then I can create an event here. So let's create a map string, and it can be any. Let's create this. So let's say type, let's say this is a joining message. Okay, so I'm just creating some quick notification structs. Okay, not struct, like JSONs. So type is join, then let's call it stream this. So this is the metadata of the new device. Okay, now for all viewers or viewer connection in the range of my room viewers, I will write the message. So now here I'll be using my safe WriteJSON. Okay, so I'll be giving the viewer connection and I will be sending the event. Okay, cool. Why is it still complaining? If I save it, now it's not complaining. Cool. Now let's get the device ID in a variable. Meta device ID, yeah. And now here's the part where we will be collecting frames from the devices. Okay, so let's write a for loop. Okay, and so let's first collect the type of message, then frame and the error message. Okay, see what read message. Okay, if error is not equal to nil, okay, then break the connection. Otherwise, if then message type. So if I see here, first I was sending the metadata. Okay, now if I look at the pump method, yeah, when the file is ready, I was sending it. Cool. So if you look at the pump method, okay, so I was transforming those frames into JPEG file formats. Okay, and then I was sending it to sending in the WebSocket connection. Okay, so yeah, so when the HTML is sending data to the WebSocket connection, it will be sending the message type. Okay, so this is for that. Okay, then with this it will get the type and then the actual frame. Okay, which is this binary object. Okay, that I will get here. Okay, and this read message implement the an error handler also, which returns this error. Okay, cool. Now if the message type is not a WebSocket binary message, okay, I'll simply continue. Okay, that's none of my work. Cool. Otherwise, now I need to create a network packet. Okay, that I will be sending to my viewers. Okay, so for that I will be using a Big-Endian notation. Okay, so first let's create the headers for my for my packet. Let's create a byte object. Okay, and here I'll be sending my device ID. Okay, so I'll be sending So let's discuss how my network packet will look like. Okay. So how I will be sending is, so I'll be sending in something kind of a this manner. Okay. So these are like standard practices when you like implement network packets. So first I will be telling, okay, the device ID. Now to collect the device ID uh, at my viewer's end, I need to tell what is my length of that device ID. Okay. So how it happens is, so we will be sending binary messages, right? So, or like we will be sending bytes directly to my viewers. Okay. Now to have some control on the bytes, okay, and to display it in proper format like this, so at my viewers end I will be having something like this kind of a view, okay, where for each room I will be having multiple screens which will be backed by all the devices that I have. Okay, like this can be for my phone, okay, this can be from my iPad, okay, and this can be from my one of my laptop, okay, and this screen will be let's say for one of my other laptop, that's it. Okay, so yeah, but I will be sending bytes. So how will this app will know which like which device is sending which frames? Okay, so in order to give that information I need to attach uh, that information in my frames. Okay, I cannot directly send frames to it. Okay, I need some distinction. Okay, so that on the app side I can verify, like I can not verify, I can know, okay, these frames are being sent by my phone, these frames are being sent from my iPad. Okay, so yeah, so for that we need to structure our payload. Okay, so I can stick to a simple structure. Okay, so let's say this is my payload. Okay, payload. So I can attach my device ID here. Okay, and later I can attach all the bytes for my frames. Okay, but yeah, here the problem is, so these are all bytes, right? So in order to strip out the device ID, okay, I need to, I can attach something like this. So the first 2 bytes, okay, can tell what is the length of my device ID. Okay, so mod of my device ID, basically length of my device ID. Okay, so now how can I use this payload is, so from the payload, okay, I'll first collect the first 2 bytes. Okay, uh, let's say something like this guy will give me the length of my device ID. Okay, so I'm just saying like how it will act in the on the app side. Okay, now if I do payload of from the second index till this length, let's call it len. Okay, so from 2 to len I will get the I will get the device ID. Okay, now payload of len plus 2 till the rest, these are my frames. Okay, so in this way I can build my packet. Okay, so yeah, I think this will be this will work. Okay, so yeah, uh, first 2 bytes I'm reserving for my length of device ID, then I'm concatenating my device ID, then I'm concatenating all the frames that I have that are being pumped. Okay, So using the first 2 bytes, I will collect the length, then I will strip off the device ID. Okay, now after that, whatever is left, those are my frames. I will deal with that for rendering. Okay, so yeah, so let's create a byte array. Let's create a length of 2 plus device ID. Okay, then I'll be creating the bytes in Big-Endian notation. I'd say binary Big-Endian, and let's create it. I think put unsigned 16. Okay, so it's singular. Let's say. So I'll be putting first the unsigned and 16, the length of my device ID. Okay. So if you guys are not familiar with Big-Endian and Little Endian, so you can have a read. Okay, so what is this concept is basically ordering of bytes. Okay, generally people stick to Big-Endian, but at some level, at the OS level, people use Little Endian. So what Big-Endian tells us that. So let's say I have this data. Okay, let's say this is my data. Okay, generally this will be like hexadecimal form. Okay, and if I'm creating a byte, okay, and in that byte, if I'm using the lowermost index, okay, to store the first chunk of my data. Okay, so that's a Big-Endian notation, like Big-Endian fashion of storing data in my byte. Okay, I think we can see some images. Yeah, so this is my byte. Okay, and let's say this is my data. Okay, so the data ordering is aligning with the memory address alignment. Okay, so this is like the lowermost memory address, this is then the next memory address, then next. Okay, so my first chunk is going to the lowermost index. Okay, and in the same fashion how my memory address is progressing, I am putting the data. Okay, but in Little Endian notation, these are like just reversed. Okay, so the smallest address gets the last byte chunk. Okay, so it gets stored in the reverse order. Okay, so generally in net like packet development, we generally stick to Big-Endian, and most of the industries like use Big-Endian notation only. So so as per my information, so like Little Endian is generally used at some OS level, which I'm not sure where, but yeah. So let's create this packet. So in the first 2 bytes, I'm putting my length of my device ID. Okay, then I will copy the actual device ID to my headers. So device ID. Okay, then I will create a payload, and that payload will be headers plus the frame I got. Okay, headers. Okay, so this payload will look just like this. Okay, so the first 2 bytes are responsible to carry my device ID. Okay, then the next byte till the length of my device. Okay, those will be carrying my device ID. Okay, and later I will just attach all the frames. Okay, so yeah, I got my payload. Now again I will be collecting all the list of viewers. Okay, then I will send out the frames. Okay, so yeah, let's collect all the viewers again. Okay, so let's put a lock. Now this will be a read lock. Okay, and then I can use the same code, room viewers, this okay, so this will give me the room viewers. Okay, then after I have collected this, I can unlock it. Okay, so I'm done with reading the data. Then I will send. Okay, so for viewer connection or the WebSocket connection to my room viewers, I will write the now I will use the WriteMessage thing. Okay, this function. Okay, so here I will put the frame like the payload here. Okay, cool. So not equal to safe write message. Okay, so here I will say the viewer connection, then I'll say WebSocket now the message type, so this is a binary message. Okay, then I will send the payload. Now if something goes wrong, what should I do? I can actually so in what scenario this can go wrong? Okay, I'm pumping up the frames to my viewers. Okay, now if something is going wrong in that way, which means the viewer is not alive or the viewer has switched his attention to some different rooms. Okay, so in that case I can simply remove out the viewer, all his connection from my data structure for that room. Okay, so yeah, so let's create an array to collect all the viewers where like writes are failing. So let's call it fail viewers. Okay, and here I will be storing WebSocket connection. Now if something goes wrong, I will simply append my fail viewers or fail connection. Let's put it fail connection. Okay, oh yeah, fail cons, and putting v here. Okay, why there is a big red line here? Oh yeah, correcting the error here. Then yeah, then why is not an expression? Oh yeah, equal to v. Cool. Now I can remove the viewers, remove all the failed connections. Okay, so connections. Cool. Now I will check if len of failed connections is more than 0. Okay, if I have some failed connection, I can put a lock again. Okay, I can say for my viewer connection in range of my fail connection. Okay, I will delete that viewer from my hub viewers mapper. Viewers, then yeah, viewers to that room. This way, yeah. This, so it contains the room, then for each room the WebSocket connection and whether it is alive or not. Yeah, so yep, room, then I can remove the connection. So yeah, so how room is storing data is, so per room is acting as a key. Okay, now in Golang we do not have sets. Okay, so I was using maps. Okay, as like as a set, so this is for that. Okay, so fail connection, so in that I'm just removing the WebSocket connection. Now I can remove that WebSocket connection from my sync map. Okay, so forget connection, so v. Okay, so why I'm doing this? Because if I'm not able to send the payload to a viewer, which means something is not right. Okay, then I should simply remove that viewer connection. Okay, but yeah, since I will be using it, so I'll be always alive. But let's say if I give this app to my friend, okay, then there will be two viewers. Okay, so in that case, this kind of handling is necessary. Just a sec. Cool. So yeah, this will be the life cycle for all the pumping that the device will be doing. Now after this, let's say the device disconnects. Okay, so let's call it cleaning up disconnects. Okay, so here if the device reconnects or like disconnects, then I need to tell to my viewers that the device is not there, right? So for that I'll be notifying it, and also I need to remove the socket connection as well as the metadata for that device. Okay, so this will be, there will be some cleanup steps here. So let's put a lock here. Okay, so locks are pretty necessary in Golang, because because Golang is based on like Go routines, right? And whenever we are doing something to the data structure and concurrency is involved, okay, so there can be data corruption, like if we are not putting logs. So this is for that. So yeah, in my ingest data structure, okay, I'll be removing the device ID, as well as I'll be removing I think one more, the stream metas, metas. So there also I will be removing this device ID. Cool. Then again I will collect all the viewers. This, let's copy this. I got the room viewers as declared in both. Let's empty this. Okay, then I don't want to use the same room viewers which I used earlier. Okay, because anything can happen. Let's say one of the viewer like disconnects here only, because I was removing the viewers, right? So I need the updated room viewers. So I'm just reinitializing room viewers here, and then I will again update it. Okay, cool. After this, after I'm done with all the changes with my data structure, I will put a unlock here. Okay, now I'll check if len of room viewers is more than 0, then I will create an event, map of string of any. I'll say type, let's call it leave type of event. Okay, then I'll say device ID. Let's create a device ID, and I can get the device ID here, right? Yeah, cool. Now let's send it out to our all the viewers. So viewer connection in range of my room viewers. So here I will be using WriteJS, my WriteJSON safe write JSON. Okay, and to this connection, this send this event. Okay, cool. And with this we are done with yeah, oh, we haven't implemented ping pong, but yeah, disconnection handler we are done with here. Okay, so the device has disconnected. Okay, then I'm just removing from the ingest, removing its metadata from the metas. Okay, then if it tries to reconnect, okay, then I'm just removing the old connection and re-registering the device. Okay, so this part is done. Then packet build. So I have created a Big-Endian based network packet. Okay, then yeah, so here I'm giving the length of the device with the device plus the frames. Okay, so on the app side, I can use this bytes to collect which device is now sending the frames. Cool. So this is done. Then locks. So I think, yeah, these methods are done, so I can safely say locks are done. So just need to implement the ping pong handler. So yeah, now how does the ping pong handler will work? Okay, I can create a new whiteboard. If I open this, both are different. Nice. Now let's bring this guy to here. Okay, and I cannot remove this. It's a pain. Yeah, it is what it is. Okay, so how the ping pong will work? Okay, so I have my hub and I have my device, right? Hub and the device. Cool. So in between them, I have this WebSocket connection. Okay. So if something goes south, okay, then I need to, so this hub needs to know like whether the device is still connected or not. Okay, whether it's able to transmit data or not. Okay, so for that, I'll be at constant time, I'll be sending some pings, right? So once this connection is established, within that connection, I'll be pinging this guy. Okay, at certain time intervals, let's say at some t time, I send this. Okay, then as a pinger, okay, I should also have some time limit. Like if I don't get any response within this time limit, then I will simply say the device is dead for me. Okay, so let's say some delta 1, so t plus delta 1 time. So within this time, if the device id doesn't send me anything, which is generally a Pong response, then I will simply say you are dead for me. Okay, and I will close the connection. So luckily Golang has methods to handle ping pong, so I just need to implement them. So yeah, so this is there, so Pong. Okay, so if the device, okay, now let's say the device sends me a Pong response. Okay, then I should update my t, okay, to some other interval, okay, at some other time. Okay, so basically this pinging should be happening at regular time intervals. Okay, and if I am sending a ping at t, okay, after some in some delta time, I should expect a response. Now if I get a response, then my next ping shall be updated to the next interval. Okay, so I can say something like let's say this length to be, let's say, t plus 30 seconds. Okay, so for every 30 seconds I'll be sending a ping. Okay, and let's say device id. Okay, so yeah, this is how the communication will be happening. So for every 30 seconds I'll be sending a ping, and I can set a limit of for like how long I can wait for the device to respond. So yeah, so just I need to implement these thresholds, and I just need to put a Pong handler, I guess. In Gorilla. Yeah, there is this ping handler. Second Pong message. Okay, cool. Okay, so let's set this. I can implement in the pumping only. So yeah, also at first I need to put some thresholds on the bytes that I will be receiving as frames. Okay, so I can set a limit. um, so first thing first, so let's say in this WebSocket connection I'll set a read limit, okay, of let's create a constant. um, let's say const max read limit, and this needs to be of 64, let's say of 1 MB, or maybe let's say 2 MB. Okay, so let's use this max read limit. Okay, so if my like message contains more than that, this will error out, so I will close out the connection. Okay, cool. Then I need to set a read deadline. Okay, so till this time I can put a uh, till this time I can put, let's say, some. So my server will be busy with the devices, so let's be kind to my server and put a bigger deadline for my Pong. Okay, so I need another constant. I'll explain you guys like what I'm doing here. So let's say max Pong limit. I think it takes time. So let's create it int 60, let's say. Then I'll say from this time till the next 60 seconds limit 62 seconds. Okay, what's happening? Cannot use this. Let's make it time to duration then. Okay. Then it shouldn't complain, right? Okay. So now let's create a Pong handler. So if this guy sends me a Pong response, what shall I do? Okay, so I will not do anything. I just need the response. Okay, so I will write a function here, and I will say okay, I'll simply I will update my Pong deadline. Say let's set read deadline to time dot now dot add, then whatever Pong limit I had, I'll change it to the next interval. Okay, lots of things. So okay, too many arguments to Pong handler. Pong handler. Oh yeah. Oh, I need to. Okay, set Pong handler. Cool. So So what I'm doing here is, at first, this is for my uh, message control, like limits for my message. Okay, now here I'm setting a deadline, okay, for my Pong. Okay, so I'm saying from current time till 60 second. Okay, I need a Pong response. Okay, like a Pong response from the device. Okay, so now this is a Pong handler. If my device sends something to me, I will update this deadline, okay, to the next Pong interval. So what will be happening is, so like here only, so at first at time t, okay, I'm setting this limit, okay, and I'm saying within 60 seconds I should get something. Okay, so this is my limit. Okay, now from this time, let's say I got a Pong response. Okay, so this limit is from t to t plus 60. Okay, so let's say at this time I got a Pong response. Now why I will do is, I will take this time, let's say t dash, then I will set the limit to, from this t dash time to the next t dash plus 60 seconds. Okay, I should get a Pong response again from the device. Okay, now let's say this guy again sends it here. From this time I will add up 60 seconds. Okay, and I will wait from this to this whether I am getting a Pong response. Okay, now in order to get the Pong response, I need to send pings, okay, at regular time intervals. So for that I'll be creating a go routine here. So okay, okay, then we'll create a ticker. Is it ticker? Yeah, let's create a ticker. New ticker. Yeah, now this will give me a ticker. So ticker is, you can think of like a time bomb. Okay, you just set something here, like you set something limit. Okay, so within this limit you should send a ping. Okay, so since my server will be busy with the connection, so I'll be, or I can send I can set my ping pong response to this same limit. Okay, let's not overcomplicate things. Okay, so I'll say let's update this max ping pong limit. Okay, so my server should send but it's better, so there can be some complication if I'm sending Pong and ping at the same time. Let's make it plus 30 seconds or something, or okay, first let's implement it. So new ticker, so this time second, so from this there will be a time bomb activated. So there let's stop this also. Okay, then I'll check if I'm getting anything in the channel. Then I'll simply do what, now I will write a message like, okay, something is done with the same WebSocket connection. Okay, then so basically I started the time bomb here. Okay, then I'm waiting for a Pong response. Okay, if I got something, then this guy will be executed. Okay, so now WriteControl will take the WebSocket connection. Now here it will take the message type. So message type will be WebSocket ping message. Okay, then do I need to write anything? Nope, I don't need to write anything. Then I can set a time limit. let's say some 5 seconds. 5 into time dot second. Okay. Let's create separate things for this. Let's stick to Pong here. Let's make this guy 60 and let's make this guy 30. Okay, so now I have changed this 60 to 30. Okay, 30 30. Yeah, so this thing, Pong limit, and here I will say ping limit. Okay, cool. So what is happening here? So yeah, so here I'm setting my deadline here. Okay, so here I'm saying from this time, okay, till the next 30 seconds I should get a Pong response. Okay, now before that, like this line is, so I have set it. Okay, then I'm just creating a Pong handler, what to do when I receive a Pong. Okay, after this I'm creating this go routine, which is starting this time bomber. Okay, and sending a ping, okay, to my device. Okay, now my device will send a message, okay, which will be handled by my Pong handler. Okay, and if I receive a Pong, now what is this Pong handler is doing? This again resets this t time, okay, by adding this Pong limit, which is like 30 seconds. Okay, so at time t I set this deadline, then I'm waiting for 30 seconds. Then after that I'm sending a ping. Now within that 30 seconds, if the device sends me a Pong response, then I'm updating the deadline to the next 30 seconds. Okay, cool. Now yeah, so why I have kept the ping limit more than the Pong limit is because my server will be busy with the viewers as well as collecting frames, right? So if I set it like very cut to cut, like my ping and Pong timings are the same, okay, I think this might fail. Okay, and it's usually a good thing to give your server some time for pinging, and you can have like lesser time for your Pong deadlines. So yeah, that's why I have kept 30 and 60. Okay, you can also put like 10 and 20. So yeah, this is a constant. Okay, I'll be like putting it in my GitHub, so later on if you guys are finding this video series helpful, you can change this code. So yeah, can implement it on your own. But yeah, for me I need like 30 and 60. That will work for me. Cool. With this I think I don't need this tab now. With this I am done with ping pong. Okay, and handle locks are done. Cool. So this is how HandleIngest will look. Okay, so let's just go through it. Okay, I'll be testing this code but yeah, in order to test it I need to create the app interface first. Okay, so that I can test it out. But yeah, let's go through our code. So we upgraded our HTTP responsive writer to WebSocket format. Then we got the stream metadata from the device. Okay, then we just unmarshaled it to our proper structure. Okay, now yeah, so here I'm handling disconnect. So if the device was earlier connected to my hub, okay, uh, then I'm just re-registering that device. I'm deleting its old WebSocket connection. Okay, then I'm notifying to all the viewers that a new device has connected. Cool. Now from here I'm setting this ping pong with my device. Okay, then yeah, I'm collecting the frame from my device. Okay, then there are some checks and error handling happening here. Okay, then I'm creating a network packet here. Okay, by creating a header, then putting the device ID in the header and then attaching all the frames. Okay, Then I'm sending this frame to all my viewers. Okay, cool. Now if one of my viewer fails, like if sending the frame to one of my viewer fails, then I'm assuming that the viewer is not connected to that room. Okay, then I'm just simply disconnecting with that viewer. Okay, cool. Now in this cycle, the pumping will be happening to all the viewers. Okay, now let's say the device disconnects. Okay, then I'm just removing that device from my ingest data structure and metas data structure. Okay, so this guy holds device id to stream metadata, and this guy hold like device id to the WebSocket connection. I'm just deleting it there. Then I'm again notifying to all my viewers that hey, this device id is gone. Cool. So I think this should work, but yeah, in order to test it, I need to implement my app interface. So let's stop here. Okay, I'll be uploading more videos, and yeah, more videos on this. So in my next video, I'll be implementing the app interface just to test out this HandleIngest. So yeah, if you guys learned something new here, and if this series is anything like helpful or giving a bit of knowledge how to code like low level programming and all that stuff, so please do like and subscribe. Okay, I need to catch that ghost. But yeah, the good thing is, so when I'm like starting this series, my board is not falling off. Okay, it's staying there. So I guess the ghost is kind of scared right now. We can say technologia syndrome. But yeah, I'll be completing this because this application has many advantages also. So because it's pretty expensive to buy CCTV cameras, right? But yeah, our phones has built-in very high quality cameras. So let's imagine like you have your iPhone with you, right? So that's already a better camera than our regular CCTV footages. So yeah, cool. So just stay tuned to watch more videos on this. Bye bye.